Welcome to the AI Prosperity Hub. Today, we'll guide you through how to build your very own AI models from scratch using both no-code platforms and code-based methods. Whether you're a beginner or an experienced developer, AI modeling is an essential skill you'll need in the future, and by the end of this video, you'll know how to create models that can recognize patterns, make predictions, and solve real-world problems. Let's dive right in. Artificial intelligence, or AI, has a rich history that dates back to the mid-20th century. From the pioneering work of Alan Turing to the development of the first AI programs, key milestones such as the creation of neural networks and IBM's Deep Blue defeating Garry Kasparov in chess have marked significant breakthroughs. Today, AI is transforming various industries, from healthcare to finance. In healthcare, AI assists in diagnosing medical conditions, while in finance it analyzes stock market trends. The automotive industry is seeing the rise of self-driving cars, and manufacturing is becoming more efficient with AI-powered robots. AI also enhances our daily lives through personalized recommendations and customer service chatbots. This transformative technology is no longer confined to research labs and tech giants. Today, individuals and businesses of all sizes can harness the power of AI to solve problems, automate tasks, and drive innovation. To get started with AI, you can use no-code platforms that allow you to build models without programming skills. These platforms offer drag-and-drop features, making it easy to create and deploy AI models. For those with coding knowledge, there are numerous libraries and frameworks available to develop custom AI solutions. Educational resources like online tutorials, courses, and workshops can help you learn and implement AI effectively. Joining community forums and support groups can provide valuable insights and assistance as you embark on your AI journey. Building an AI model might sound daunting, but the process has become increasingly accessible in recent years. There are now two primary approaches to building AI models: no-code and code-based. No-code platforms, as the name suggests, allow you to create AI models without writing a single line of code. These platforms use intuitive drag-and-drop interfaces and pre-built modules to simplify the model-building process, making AI accessible to a wider audience. Examples of no-code platforms include Google AutoML and Microsoft Azure Machine Learning Studio. On the other hand, code-based platforms require programming knowledge, typically in Python, and offer greater flexibility and customization. Popular code-based tools include TensorFlow, PyTorch, and scikit-learn. Google's Teachable machine simplifies AI creation, making it accessible to everyone online. You can create machine learning models without any coding. Train it to recognize objects, sounds, or poses by example. That's the power of Teachable machine. Upload your data, train, and test in real time. It's perfect for beginners, educators, or anyone curious about machine learning. Let's dive into creating a simple image recognition model with Teachable machine. Imagine you want to train a model to distinguish between photos of apples and oranges. The first step is to gather a collection of images for each category. You can use your own photos or find images online. It's important to have a diverse dataset with variations in lighting, angles, and backgrounds to improve the model's accuracy. Once you have your images, navigate to the Teachable machine website and select the Image Project option. You'll be presented with a simple interface with designated areas to upload your images for each class. Label these classes clearly, for example, apples and oranges, to help the model learn the distinctions. After uploading your images, click on the Train Model button to start the training process. The system will process the images and train the model to recognize the differences between apples and oranges. Once training is complete, you can test your model by showing it new images and seeing how well it performs. With a well-trained model, you should see high accuracy in distinguishing between the two classes. Exploring audio and pose recognition. Teachable machine allows building models for audio classification and pose estimation. Collect audio samples for each category. For example, record separate sounds for a dog barking and a cat meowing. Upload and label these samples, then train the model. Test the model with new audio samples or a microphone. For pose recognition, capture different poses using a webcam. Label each pose and train the model. Test the model by performing new poses and see the results in real time. Use cases include fitness tracking, dance move recognition, and interactive games. Advantages and limitations of Teachable Machine. Teachable Machine's strength lies in its simplicity and accessibility. Its intuitive interface requires no coding knowledge, making it ideal for beginners. This empowers educators, artists, and creatives to easily integrate AI into their work. Real-time training provides instant feedback, which is crucial for iterative learning. Its web-based nature eliminates complex setups, allowing for quick deployment. Available on any device with a web browser, it offers great flexibility. However, compared to traditional coding approaches, it lacks the depth and customization that experienced developers might need. Traditional coding allows for more control and fine-tuning of AI models, which can be essential for advanced projects. While Teachable Machine is excellent for quick, accessible AI projects, traditional coding remains superior for complex, highly customized solutions. Embracing the power of code. While no-code platforms like Teachable Machine provide an excellent entry point into the world of AI, true flexibility and control over your AI models come from embracing code. Python, with its clear syntax and extensive libraries, has emerged as the go-to language for AI development. Coupled with powerful frameworks like TensorFlow, building sophisticated AI models becomes a structured and efficient process. TensorFlow, developed by Google, provides a comprehensive ecosystem for building and deploying machine learning models, including neural networks. Its flexible architecture allows for running models on various platforms, from CPUs and GPUs to mobile devices and large-scale distributed systems. Embracing coding in AI development empowers you to tailor your models precisely to your needs, ensuring optimal performance and innovation. Setting up your AI workshop. Before embarking on your code-based AI journey, it's crucial to set up your development environment. Think of this as preparing your AI workshop with the necessary tools and materials. Step 1. Install Python on your system. Python's official website provides installers for various operating systems, making the process straightforward. Step 2. Install TensorFlow. Once Python is installed, use the pip package manager to install TensorFlow. TensorFlow offers different installation options depending on your operating system and whether you have a compatible GPU. Step 3. Set up an integrated development environment, IDE, like PyCharm or VS Code, to write and test your code efficiently. Step 4. Ensure you have a powerful computer with a good CPU and preferably a GPU to handle intensive computations. Step 5. Install additional libraries and tools like NumPy, Pandas, and Jupyter Notebook to enhance your development experience. With these steps, your AI workshop will be ready for any project you undertake. Importing libraries and data preparation. With your environment set up, the first step in building a code-based AI model is to import the necessary libraries. Think of libraries as pre-built toolboxes containing functions and modules that simplify common tasks. In your Python script, begin by importing TensorFlow, typically abbreviated as TF. This gives you access to all of TensorFlow's functionalities for building and training your model. Next, import NumPy, often imported as NP, for its powerful numerical computation capabilities, particularly working with arrays and matrices, which are fundamental data structures in AI. Best practices include importing only the libraries you need to keep your code efficient and readable. A common pitfall is forgetting to install the libraries before importing them, which can lead to import errors. Always ensure your libraries are installed and up to date to avoid compatibility issues. Comment your code to document why each library is imported, making it easier for others to understand and maintain your code. Constructing your neural network. Let's dive into the architecture of your neural network, the core of your code-based AI model. Neural networks are inspired by the human brain and consist of interconnected nodes called neurons, organized in layers. Each connection between neurons has a weight, which determines the strength of the connection. Training a neural network involves adjusting these weights to minimize prediction errors. TensorFlow makes it easier to define and build neural networks. Begin by creating a sequential model, which is a linear stack of layers. The learning process. Training your model. With your neural network architecture defined, it's time to train your model using the prepared data. Training a model is analogous to teaching a child to recognize patterns. The quality and quantity of your training data are crucial. High-quality, well-labeled data helps the model learn effectively. TensorFlow makes this process straightforward with the compile and fit methods. The compile method configures the learning process by specifying the optimizer, loss function, and metrics. The optimizer determines how the model updates its weights based on the calculated error. Optimizing the training process involves fine-tuning these parameters and using techniques like cross-validation to ensure the model generalizes well to new data. Evaluating model performance. After training your model, it's crucial to evaluate its performance on unseen data to assess its generalization ability. This is where the testing set, which was kept separate during data preparation, comes into play. TensorFlow's evaluate method provides a convenient way to assess the model's performance. By providing the testing data to the evaluate method, you obtain metrics such as loss and accuracy, indicating how well the model generalizes to new, unseen data. Visualizing the model's performance can provide further insights. Key evaluation metrics include precision, recall, and F1 score. Precision measures the accuracy of positive predictions. Recall measures the ability to find all positive instances, and the F1 score balances precision and recall. Additionally, the ROC curve and AUC provide insights into the model's performance across different threshold settings, helping to understand the trade-offs between true positive and false positive rates. A guide to deploying AI models. Once you're satisfied with your trained AI model's performance, it's time to deploy it to make it accessible to others or integrate it into real-world applications. TensorFlow offers various deployment options depending on your specific needs and the scale of your project. One option is to save your trained model to a file. This method is straightforward and allows for easy sharing and reuse. TensorFlow provides the save method, allowing you to save the model's architecture, weights, and training configuration to a file that can be loaded and reused later. This saved model can be shared with others, allowing them to utilize your trained AI model without retraining it from scratch. Another option is cloud deployment, which offers scalability and accessibility but may incur additional costs and require internet connectivity. Edge deployment is ideal for low-latency applications and offline use, but may be limited by the hardware capabilities of edge devices. Each deployment option has its pros and cons, so choose the one that best fits your project's requirements and constraints. Preparing your AI development environment. Before diving into AI model creation, set up your development environment. First, install Python on your system. Next, install TensorFlow using pip, the package manager bundled with Python. Consider installing Anaconda for managing packages and environments. Use an IDE like Visual Studio Code for writing and debugging your code. Finally, use GitHub for version control and collaboration. Importing essential libraries. With your AI development environment primed and ready, the first step in building a code-based AI model is to import the necessary libraries. Think of libraries as specialized toolboxes, each containing a collection of pre-built functions and modules designed to simplify common tasks. In your Python script, you'll begin by importing TensorFlow, often abbreviated as TF. TensorFlow is a powerful library for numerical computation and machine learning, providing the building blocks for constructing and training your AI model. This simple import statement grants you access to the vast capabilities of TensorFlow, enabling you to build and train complex neural networks with ease. Next, you'll import NumPy, conventionally imported as NP. NumPy is essential for numerical computations, particularly for handling arrays and matrices. NumPy's strength lies in its efficient handling of arrays and matrices, which are fundamental data structures in the realm of AI. This library allows you to perform complex mathematical operations with ease, making it indispensable for AI development. Preparing your data for AI projects. Data preparation transforms raw data into a format your AI model can understand. It's like preparing a meal for a guest with specific dietary needs. Start by loading your dataset from its source. Clean the data by handling missing values and removing duplicates. Normalize and scale your data to ensure consistency. Engage in feature engineering to enhance model performance. Finally, split your data into training and testing sets to validate your model. Let's start by understanding the architecture of your neural network. These networks, inspired by the human brain, consist of interconnected nodes called neurons. Each connection has a weight, which determines the strength and flow of information. Training involves adjusting these weights to minimize errors. First, define your neural network using a framework like TensorFlow or PyTorch. Set up the layers and choose activation functions for each layer. Compile the model with an optimizer and a loss function to guide the training process. Finally, train your model using your dataset and monitor its performance. With your neural network architecture defined, it's time to train your model using prepared data. Think of it as teaching a child to recognize patterns, presenting labeled examples from your training data, and adjusting internal parameters for accuracy. TensorFlow's compile and fit methods streamline this. Compile sets up the optimizer, loss function, and metrics to track progress. After training, evaluate your model using test data to see how well it performs. Interpret evaluation results to identify areas for improvement. Refine your model by adjusting parameters and retraining to enhance performance. Congratulations! You've meticulously crafted a neural network, painstakingly trained it with well-prepared data, and witnessed its predictive prowess during evaluation. Now it's time to unleash your AI model into the real world, allowing it to spread its wings and make a tangible impact. This crucial step, known as deployment, bridges the gap between a trained model and a functional AI application. TensorFlow, never one to disappoint, offers a range of deployment options tailored to various needs and project scales. One straightforward approach is to save your meticulously trained model to a file. TensorFlow provides the aptly named save method, allowing you to preserve your model's architecture, its learned weights, and the training configuration in a single file. Another option is cloud deployment, which offers scalability and accessibility. Cloud services like AWS, Google Cloud, and Azure provide robust platforms for deploying AI models. For real-time applications, edge deployment is ideal, bringing the model closer to the data source. This reduces latency and can be crucial for applications like autonomous vehicles and IoT devices. Each deployment option has its pros and cons. Cloud deployment offers flexibility but can incur higher costs. Local deployment is cost-effective but may lack the scalability of cloud solutions. Choose the deployment strategy that best aligns with your project's requirements and constraints. AI in image recognition and computer vision has come a long way. Image recognition, a cornerstone of AI, has witnessed remarkable advancements. AI models trained on massive datasets identify objects, scenes, and faces with astonishing accuracy. This capability has revolutionized industries and enhanced our daily lives. In healthcare, AI-powered image recognition assists medical professionals with diagnosis. In transportation, AI enables autonomous vehicles to navigate and analyze traffic conditions. In retail, AI helps manage inventory and analyze customer behavior to enhance shopping experiences. In security, AI-driven surveillance systems detect suspicious activities and enhance public safety. In agriculture, AI-powered drones monitor crops and analyze soil health to optimize yields. Beyond the visual realm, AI has made significant strides in understanding and processing audio data, opening up exciting possibilities in speech recognition, music generation, and sound classification. AI models, trained on vast datasets of speech and audio recordings, have become remarkably adept at transcribing speech to text, translating languages, and even composing original music, blurring the lines between human and machine creativity. Virtual assistants such as Siri, Alexa, and Google Assistant have become ubiquitous, seamlessly integrated into our smartphones, smart speakers, and other devices. These voice-controlled companions rely heavily on AI-powered speech recognition to understand our commands, answer questions, set reminders, and even control smart home devices, making our lives more convenient and connected. Techniques like neural networks and deep learning have revolutionized audio processing. For instance, neural networks can be trained to recognize speech patterns and accents, while deep learning models excel at understanding context and nuances in language. Natural language processing, NLP, further enhances these capabilities by enabling real-time translation and sentiment analysis. These advancements showcase the transformative power of AI in audio and speech processing, making technology more intuitive and accessible. Data analysis techniques. Unlocking insights from data. Data analysis techniques like predictive analytics, clustering, and regression help forecast future outcomes, identify patterns, and make data-driven decisions. Predictive analytics forecasts future events based on historical data, while clustering groups similar data points to uncover hidden patterns. In finance, regression analysis helps in risk assessment and fraud detection by identifying relationships between variables. AI models flag suspicious activities in real time, protecting against financial losses and optimizing operations. Exploring creative applications of AI. AI is pushing the boundaries of art, music, and storytelling. AI models generate stunning visual art, original music, and compelling narratives. AI-generated art rivals human artists, sparking debates about the nature of art. Innovative projects like AI-driven fashion design and AI-composed symphonies are transforming creative industries. AI's impact extends to film production and scriptwriting, revolutionizing how stories are told. The democratization of AI. Building and deploying AI is no longer confined to research labs and tech giants. No-code platforms and accessible coding tools like Python and TensorFlow have democratized AI. Now anyone can explore AI, from educators to artists, without writing a single line of code. This accessibility is transforming various fields, enabling innovation and efficiency. As AI becomes more integrated into our lives, it holds the potential to revolutionize industries and improve our daily experiences. The future of AI is inclusive, empowering individuals and communities worldwide to harness its power for positive change. Embracing the future of AI. The journey into the world of AI model building, whether you choose the no-code path or embrace the power of code, is an exciting and rewarding one. As AI continues to evolve at an unprecedented pace, the ability to understand, build, and deploy AI models will become increasingly crucial, not just for tech professionals, but for individuals across all walks of life. Emerging trends like AI-driven healthcare, autonomous vehicles, and smart cities are just the beginning. AI has the potential to revolutionize industries, making processes more efficient and creating new opportunities. The future promises even more intuitive no-code platforms and increasingly powerful code-based tools, further lowering the barriers to entry and empowering a new generation of AI practitioners. The key takeaway is this: the best time to dive into the world of AI is now. Embrace the future and be part of the transformation. And there you have it, a complete guide to building AI models using both no-code platforms like Teachable Machine and code-based methods with Python and TensorFlow. Whether you're just getting started with AI or looking to take your skills to the next level, these tools are essential for anyone interested in the future of AI. Make sure to try them out for yourself and see what amazing projects you can build. If you found this tutorial helpful, don't forget to like this video, subscribe to the AI Prosperity Hub, and let us know in the comments what AI topic you'd like us to cover next. Thanks for watching.